Dear students, welcome to EEC. I am Dr. P. Suresh. In today's video class, we are going to discuss regarding the formation of bus admittance matrix. In other words, we can call as Y-bus matrix. So how we can form this matrix, bus admittance matrix? Actually, what is the use and what is admittance matrix? So bus admittance matrix relates bus currents to bus voltages. So these things you would have studied in the power system. So actually it is its main functional or fundamental for performing power flow analysis, stability studies and fault analysis in a power system. So we can perform the power flow analysis. So power flow analysis is used to find the different voltages in different buses. And the stability analysis, how the power system is performing. And fault analysis, so for a power system, if fault occurs, what is the current in the bus or what is the current in the faulted part? So these things can be analyzed. So for these cases, we need this Y-bus matrix. So for formation of Y-bus matrix, there are different methodologies we can perform, we can have. The first method is known as direct inspection method. So this is the most common and straightforward approach for small to medium sized networks. And second case is singular transformation method. So this is a systematic algorithmic approach best suited for computer programming. And then the third method is step by step, or we can call as bus building algorithm. So step by step we can form this matrix. So these are the different methods that can be used for forming the Y-bus matrix. So in today's class, we are going to discuss regarding singular transformation method, the second method. So how the Y-bus is formed, bus admittance matrix is formed. So for forming the bus admittance matrix, we have some steps to be followed. So if you are using all these 7 steps, it is easy for you to form Y-bus matrix. So the steps are given. Step number 1 is drawing the graph. So we will be given a power system. For the given power system, you have to draw the graph. So graph is nothing but it is just the representation of the buses and the transmission lines, how they are connected. That is a graph. And second one is called as tree. I think a graph you would have studied this. And a tree. So tree is nothing but again it is like a graph. So that is giving you information like how the buses are connected. Actually, we have to connect all the buses, but after connecting the buses, it won't give any closed path. So that is called as tree. So we can form more number of trees. Among the trees, we are going to consider only one tree for this Y-bus matrix. Step number 3 is form bus admittance matrix. Bus incidence matrix. So that is we can call as A matrix. A represents the incidence matrix. So this matrix is to be formed from the tree which we have already created. Step number 2. So tree is created. From the tree we are going to form bus incidence matrix. And step number 4 is we have to transpose the matrix, A transpose. And step number 5 is we have to form the primitive impedance matrix. So this is called as ZP. Impedance is represented as Z. So P is nothing but primitive. So impedance primitive matrix or primitive impedance matrix. And step number 6 is primitive admittance matrix. So this is YP. So from ZP matrix we can form YP matrix by just inverting the elements. And finally step number 7 is forming the Y-bus matrix. So this Y-bus matrix is formed using all the previous steps. So we already found A matrix and A transpose and then YP. Using all these matrices, we can form Y-bus matrix. So Y-bus matrix is equal to A, YP, A transpose. So these are the steps. So 7 steps are there. So using these steps, we will solve a problem, numerical problem. So you can see here, this is the numerical problem given. So you are asked to construct bus admittance matrix by singular transformation method where the impedances are labeled in per unit. So this is nothing but the power system. So if you take the power system is consisting of buses. So you can see here bus number 1 it is given, and second bus is given, and then third bus, and then fourth bus. So these buses 1, 2, 3 and 0, among all these 4 buses, this 0 is nothing but the reference bus. So this is called as reference bus. In some cases, instead of 0, it will be starting with 1, 2, 3, 4. So if the buses are starting from 1, 2, 3, 4, the bus number 1 will be treated as reference bus, or else in the problem itself it will be noticed which is reference. So here as 0 it is given here, so we will be taking 0 as the reference bus, and you can see the values J 0.4 here. So this is nothing but impedance value. This value is nothing but impedances. So this is given in per unit. So this is nothing but transmission line parameter. This is the transmission line. The transmission line connects bus number 1 and bus number 2. So this is transmission line. So it is impedance value. It is given in per unit. So J 0.4. Similarly, all the other buses are also connected through the transmission lines. So if you take the second bus and the reference bus, you can see it is J 1.25. So this is per unit. So J2 here from 3 to 0. So we have the impedances and then buses, transmission lines, how they are connected. So for this case, we are going to form bus admittance matrix. So normally if your problem is given, you are asked to find the Y bus matrix. Okay, so Y bus matrix, and as this is going to be a matrix, so the bus it will be having some rows and columns. That is nothing but matrix, rows and columns. So after forming the bus matrix, what is the size of the matrix? What will be the size of the matrix for the Y bus? Okay, so normally the Y bus matrix, the size of the Y bus matrix depends upon the number of buses. So if you see here, we have number of buses. So we have buses here, it is taken as 4. Among the 4 buses, one bus is taken as reference bus. So leaving reference bus, how many buses are there? We have 3 buses. So those buses are 1, 2 and 3. There are 3 buses now. So we should not consider a reference bus. Leaving reference bus, how many buses are there? So there are 3 buses. Then the size of the matrix will be 3 cross 3. So after forming the Y bus matrix, we will be arranging a matrix. The size of the matrix will be 3 by 3. So this matrix will be having elements. You know, this is the matrix. After forming, we are going to form the matrix. This is 3 by 3 matrix. This is 3 by 3 matrix. Then how many elements are here? So we have 9 elements. 1 here, 1 here, 1 here. So similarly, so 6, 9. So 9 elements will be available. So we are going to form this matrix, Y bus matrix. Right. So this is the problem. For this problem, we are going to form Y bus matrix. So for that, we are going to go for step-by-step procedure. So first, we are going to draw the graph. That is the first step. And second step is, from the graph, we are going to draw the tree. So first, we will draw the graph first. So normally, for drawing the graph, simply we are going to connect the elements using a straight line, or we are going to connect the buses using a line. That's it. That is nothing but graph. So for this case, just take the buses. So you can see here bus number 1 is here. So I am going to take bus number 1 here, bus number 1, and second thing is bus number 2 is here, bus number 2, and bus number 3 is here, and you can find the reference bus here. So this is your reference bus. So you can find a bus here, 1, 2, 3, and then reference bus. So these buses are given. So we are going to join the buses. Okay. So see here, for the first case, if you take this element, you know, that element is connected between bus number 1 and 2. So this is bus number 1, and I am going to join bus number 2 like this. And if you take this one, okay, so that is connected between bus number 1 and 0. So I am going to connect bus number 1 and 0 like this. And you can take this one. So this is connected between bus number 2 and then 0. So I am going to join like this. And you can see here this element that is connected between bus number 1 and 3. So if we take this as bus number 3, I can join like this. And similarly for this case that is connected between 2 and 3, so I am going to join like this. And next one is buses 3 and 0 are getting connected. Okay, so I am going to join like this. So this is nothing but graph. So what I did actually, I did not mention any impedance values. Just I connected all the buses through lines. These lines are representing transmission lines actually. These numbers are nothing but buses. Okay, so just draw by connecting the buses with a line. So that is called as the graph. After the graph, first step, after the graph, we are going to go for orientation graph. So orientation graph is nothing but it is giving you the information like how the flow of power is going to take place or how the current flow is going to take place. Right. So normally we are going to represent the orientation graph using an arrow mark, some arrow mark. Right. So how the arrow mark is allotted here. So if you take the buses, if you take all the 4 buses, so if you take the first bus, for instance, if you take the first bus, for this first bus, the 3 lines are connected. The first line is connected between 1 and 2, 1 and 3, 1 and 0. All the 3 lines are connected. So we are going to form the orientation graph. So orientation graph is nothing but making an arrow mark. So for making the arrow mark, how the arrow mark should be made, whether the arrow mark goes out or coming in. So simply you follow all the lines, all the arrow marks. So that should be going out from the bus. So if you take the first bus, if you take the first line, so this is the first bus, this is the first line. So for this case, I am going to draw arrow mark that is going out like this. And for the same first bus, you can see here this line. If you take the line which is connecting 1 and 3, for this case also the arrow mark should go out. And also this line, the line connecting 1 and 0, for this case also I am going to form the arrow mark that should go out. So for the first bus, the 3 lines are connected, I made the arrow marks are going out. And similarly for the second case, second bus, you take the second bus. For the second bus also there are 3 lines. Okay, so if you take the line number 1 and the line which is connecting 1 and 2, it was earlier given the arrow mark. So we should not consider again. So leaving that, we have 2 lines. So for this case also, we have to take the arrow mark that is going out like this. So 2 and 3, the arrow mark goes out. And also 2 and 0, this also going out like this. You can see here, for the second bus, 2 arrow marks are going out. Right. Consider third bus. For the third bus also, we have to take the arrow mark should go out like this. So for all the buses, the arrow mark should go out. Right. So we formed the orientation graph. Now we are going to assign some values or names for the transmission lines, because the transmission lines are given some values, J.4, J.2 like that. So instead of that, we are going to assign some names. So how the names are taken? So normally the names are taken like this. The names are taken as A, B, C, D, etc. Like this we are going to take A, B, C, D. Right. So how the element names are assigned actually. So if you take the first bus, this is the line coming out. I will be taking this as A. And for the second bus, this is coming out. So I will be taking this as B. For the third bus, I will be taking C. So bus number 1, 2 and 3, see the arrow marks are going out. So I will be taking A, B, C like this. For other cases, it is our wish. So assign the value. So A, B, C is over. Then I can also take this as D and this is E and this is F. So this A, B, C, D, these are all called as, we can call these as branches. We are calling as branches. So branches, the names are assigned A, B, C, D, E, F like that. Right. So this is the first step number 1. Right. Coming to step number 2. So what is a tree? So tree is nothing but it is also a graph. It is also a graph that is going to represent the connection between all the buses. The line which is going to connect all the buses, but after making the connection between the buses, it should not give any closed path. That is called as a tree. Right. So I will draw a tree. So we can draw number of trees, but I will be taking only one tree for our problem. Okay. So first I will take the bus number 1. So this is bus number 1, and I will be taking this as bus number 2. Same, I will be taking this as bus number 3. I will be taking this as bus number 0. Right. So we are going to connect all the buses, but it should not make any closed path. So how I can make? So I can join like this. So I can connect 1 and 3. I can connect 2 and 3. I can connect 3 and 0. You can see all the buses are connected. All the buses are joined. The connection between 1 to 3, 2 to 3, 0 to 3, all the things are joined, but it is not forming a closed path. Right. So now this is called as tree. This is called as tree. So the lines which are going to join all the buses, which is not going to create any closed path, that is called as tree. But after leaving the tree, we have connections. So already you can see here the element F. F is also connected between 1 and 2. Right. So that F is called as co-tree. So I am going to make the co-tree. So the co-tree should be made with a dotted line. So this is nothing but the co-tree. So this is your co-tree, and again you can find D is also a co-tree, and E is also a co-tree. So this is the co-tree. So after making that, I will be assigning the values like A, the element value is B, and this is your C, and this is your D, and this is your F, and this is E. So this is called as tree. So first one is called as graph, second one is called as tree. Right. So this is step number 2. And coming to after making all this, so this is the graph which is going to show you graph and then tree like this. Right. So after this we are going to go for step number 3. For step number 3 we are going to consider the tree. Okay. So 3 is nothing but forming the or find the bus instance matrix, A matrix for the tree. Okay. Right. So for the bus instance matrix we are going to consider the tree. So tree is already we have the tree here. So this is given here. So we are going to form the matrix. This is a matrix, A matrix, instance matrix. It is a A matrix. So I am going to form the A matrix. So A matrix, I am going to form A matrix. So as we are talking about matrix, the matrix will be having a size. The matrix will be having a size. What is the size of the matrix? So normally if you take this this tree, we have 4 buses and we have 6 elements. 4 buses and 6 elements, and the size of the matrix will be giving you number of buses cross number of elements, number of branches or elements. So how many buses are here? So how many buses are here? We have 4 buses actually. So we are going to leave the reference bus. Leaving the reference bus, we have 3 buses. How many elements are here? Number of elements will be 6. Then the size of the matrix will be 3 cross 6. So A matrix will be like this. So it is 3 cross 6. So it is the matrix. We are going to form a matrix 3 cross 6. So this is 3 cross 6. So if we take a matrix will be having rows and columns. All the vertical elements we are calling as column. All the horizontal elements we are calling as rows. Okay. So what is taken in column? What are the things taken in rows? Okay. So in the column, in the column we are going to consider the buses. So how many buses are there? There are 3 buses. Bus number 1, bus number 2, bus number 3. We are not going to consider bus number 0. So we are having bus number 1 here. So bus number 2 here and bus number 3 here. 3 buses. And how many elements are here? 6 elements. Those elements are taken horizontally. So this is A, B, C, D, E and then F. So totally how many elements? We have 18 elements. We have 18 elements. So how the elements are assigned? So for assigning the elements, A, B, C, D and then 1, 2, 3, so these elements, we are going to form. So for this case, we have to consider the branches. So first we take, say here, A is the branch and 1 is the bus. So if you consider here, A, you can see here A is here. A is here. That is connected with the bus number 1. A is connected, this branch is connected with the bus number 1 and also this branch is connected with the bus number 3. So this particular branch is related to bus number 1 and bus number 3. Right. So we are going to assign the values. So these values will be in terms of 1, -1 or 0. So how we are going to assign? So if you consider this branch A, this branch A is coming out from the bus number 1. Coming out from the bus number 1. Whenever a branch is coming out from the bus number 1, we have to consider, we have to assign +1. Correct. So I am considering branch A. Branch A is connected with the bus number 1 and bus number 3. When the branch is considered, when the branch is coming out from the bus, that is given as +1. Okay, correct. Right. And coming to B. So you can see here B. B is this branch, but that is not related to bus number 1 because we are considering only bus 1. So in bus 1, what are all the branches connected? So A is connected with the bus 1. So the bus, the branch is coming out, the RMR comes out. So I entered as 1 here, +1 here. But if you take branch B, that is not related to bus number 1. If you consider B, that is not related to bus number 1. So if there is no relation between the branch and then bus, then we have to assign 0. And similarly, if you take the C, branch C here, you can see here C. C is not also related to bus number 1. So again it is 0. Again it is 0. So if you take D, so D is related with the bus number 1. So it is coming out. So D is given as 1. Because why I am making as +1, the RMR comes out. So D is given as 1. I will take E. There is no relation between bus number 1 and E. It is 0. And if you take F, so F is also coming out from the bus. So it is taken as 1. Now I considered bus number 1. For this bus number 1, what are all the branches connected? You can see here. If you take bus number 1, A is connected, F is connected, D is connected. But also all the arrow marks are coming out. So it is taken as 1 +1. If there is no connection between buses and then branch, it is taken as 0. Okay, so now the first bus is over. And coming to second bus. So in this case, what are all the branches in connection with the bus number 2 we are going to take? Right. So if you take branch A is here, bus 2 is here. So there is no connection between branch A and bus 2. So it is 0. And similarly, if you take branch B is connected with the bus number 2 and also the arrow mark is coming out. You can see here bus number 2 is connected, the branch B, the arrow mark comes out. So comes out means it is 1. And if you take C, there is no relation between bus number 2 and C. So it is 0. And if you take D, again there is no relation between bus number 2 and D. It is 0. And if you take E, so if you take E, you can see here E. So for E, it is coming out from the bus number 2. So it is 1. And F, you can see here F is here. So for this case, the arrow mark goes into the bus. The arrow mark goes into the bus. Same branch F, the arrow mark is coming out from the bus number 1. but for the same branch it is going into the bus number 2. So whenever the branch is going into the bus, it should be taken as -1. So it is -1. So now bus number 2 is over. And coming to bus number 3. So similarly, we are going to take branch A. So for the branch A, as you can see here, branch A, it is going into the bus number 3. So whenever the branch is going into the bus, it should be taken as -1. So it is -1. So what about B? So B is also coming in. So B is coming in, it is -1. What about C? From the bus number 3, C is coming out. So it is 1. And what about D? There is no relation between bus number 3 and D. So 0. And what about E? So E, there is no relation. And what about F? There is no relation. So it is 0. So by this way, we formed the bus incidence matrix or A matrix. So after forming, we found the value like this. So on the left hand side, we considered the buses 1, 2, 3. We are not considering the reference bus 0. We have to leave that. And on the horizontally, row wise, we are going to take the branches. So those branches are A, B, C, D, E, F. And what is the relation between the bus and branch? So everything is given. So this is nothing but A matrix, right? So this is step number 3. And step number 4 is finding the A transpose. Finding A transpose. So transpose is nothing but all the columns, from the matrix, all the column are changed into row. And rows, rows are changed into column. So when you change rows into column, column into rows, that gives the transposed matrix. So we have A matrix. So we are going to form A transpose. You can see here. Now the size of the matrix is 3 cross 6. So now this is A matrix. When this is transposed, you can have the transposed matrix, the size of the matrix will be 6 cross 3. Because why we are going to take 6 cross 3? Because the branches will be taken as column and then buses will be taken as rows. So that is why. So it will be changing. Now after changing the matrix or transposed, then we can get the transposed matrix like this. So in this case, this is bus number 1 and this is bus number 2 and this is bus number 3. So here the buses are in column wise. Now it becomes a row. And also this is taken as branch A, this is B, C, D, E and then F. Now I change the rows into columns. You can see here 1 0 0 1 0 1 1 0 0 1 0 1. It is in horizontally, that is rows. Now it becomes column 1 0 0 1 0 1. So this becomes column here. And similarly the second row, that becomes second column. The third row becomes third column. Now this is step number 4, A transpose. Now the A matrix is transposed. A transpose. Right. Now coming to step number 5. Step number 5 is nothing but the formation of primitive impedance matrix. So primitive impedance matrix is nothing but, so we are going to form Z matrix. Z is nothing but there are impedances. Impedance matrix. We are going to form impedance matrix, ZP matrix. And we know that in the problem itself, all the branches, transmission line branches are given in terms of impedances. Okay, so this J, J 0.4, this is impedance. J 0.2, this is impedance. J 1.0, this is impedance. So using these impedances, we are going to form the primitive impedance matrix. Right. So it is going to be matrix. So now we are going to form the matrix. So that matrix is ZP matrix. So what is the size of the matrix now? Again, if you are talking about matrix, the matrix will be having the size. What is the size of the matrix? So for ZP matrix, the size of the matrix will be number of branch or element, number of branch cross number of branch or number of element. So how many number of branches are here? Number of branches are 6. So here it is 6. So here it is 6. So the size of the matrix will be 6 by 6. So there are 36 elements. We are going to form 36 elements. So 36 elements are to be filled here. So how we are going to fill the elements? Before that, column wise we are going to take number of branches A, so it is B, C, D, E and then F, and similarly row wise it is A, B, C, D, E and then F. So that is 6 by 6 matrix, right? So we are going to fill the elements, so all the elements are to be filled. Right? So how the elements are filled? So if we take this first element, so this particular element, this element is related to branch A and branch A. So this is related to branch A and branch A. Okay, so we are going to assign the value here for branch A and branch A, and this is nothing but this is the branch connected between actually this is the impedance value here. This is nothing but this value will be giving you the impedance value between A and B. This will be giving you the information or impedance value between A and C. This is A and D, A and E, A and F. Likewise we are going to give the values here. So first you take the first element here. So this is A and A. What is the element? So for this case you take the graph. So this is A. This is nothing but A. So if we take this A, this impedance is connected between 1 and 3. So this is connected between 1 and 3. Similarly, if you take this diagram here, given problem, what is the value of the branch which is going to connect between buses 1 and 3? That is nothing but J 0.2. So here A, the branch is we are naming as A, the value of A is nothing but J 0.2. So the impedance value of A, that is called as self impedance, that value is taken as J 0.2. So it is J 0.2. Can we have the value of impedance which is going to be making a impedance between A and B? No, there is no impedance or mutual impedance between A and B. You know what is meant by self impedance? What is the meaning for mutual impedance? So there is no mutual impedance between A and B. So if there is no mutual impedance between A and B, that will be taken as 0. And also there is no connection between mutual impedance between A and C, A and D, A and E, A and F. No. Right. So now the self impedance between A and A is written here. A and B is written here. A and C, A and D similarly. And similarly for the second one, this value. So this is nothing but the mutual impedance connected between A and B. So again there is no mutual impedance between A and B. So it is taken as 0. So for this point, what is the impedance connected between or self impedance connected between B and B? So where is B? So this is B now. So this is B. What is impedance value for B? It is J 0.2. J 0.2. So we are going to write the value as J 0.2. And similarly other values will be 0 because there is no mutual impedance between B and C, B and D, B and E, B and F. So now second row is over. Similarly for the third case. For third case also, what is the mutual impedance between C and A? There is no value. And also for C and B there is no value, 0. And what is the impedance value between C and C? So this is C. The value of C is this one, J2. Okay, because this C is the branch which is connected between 3 and 0. The value of the C is nothing but J2. So we are going to take this value as J2. Other things are zeros. So normally if you take the bus primitive impedance matrix, only diagonal elements will be having the values, half diagonal elements will be, the values are zeros. So I will be taking those values as all the half diagonal values will be taken as 0. So this is 0, and for D also this is 0. For D, so you can see here this is D. What is the value of D here? It is J 1.0. So it is J 1.0. So this is diagonal element A, B, B, C, C, D, D, E, F, F. Those are all diagonal elements. All the half diagonal elements will be 0. So this is 0, this is 0, and this is 0, and this is 0. What is E? Where is E here? E is given here. So the value of E is here. It is J 1.25. J 1.25. Other elements are zeros here. And taking F. So for this F, the value is taken as J 0.4. So this is J 0.4. So this is called as ZP matrix. This is called as ZP matrix. This is primitive impedance matrix. All the values are impedances. Okay, right. Step number 6. We are going to form bus or primitive admittance matrix. So already we derived Z matrix. Now we are going to form Y matrix. ZP is formed. Now we are going to form YP matrix. So normally we know the formula for Y. Y is equal to 1 by Z. Inverse of impedance. That is called as admittance. We are going to form admittance matrix. This matrix is formed using ZP matrix, impedance matrix. So what we are going to do? Just you are going to invert all the values. Simply inverting the element. Okay. So if you take the first element AA. So AA, already the value of ZAA, it is given as J 0.2. We are going to form Y. Y is nothing but 1 by Z, which is equal to 1 by J 0.2. 1 by J 0.2. And you know how to use the calculator. Using the calculator, if you invert the value, that becomes minus J5. Okay. Now we formed the value here. And all other rows will be 0. So you can see here 0, 0. All the values are zeros. And similarly, for this case, J 0.2, same value. This also J5. And for this case, J2, the value is minus J0.5. Similarly, for this case it is J1.0, minus J1.0. For this case, it is minus J0.8. For the last case, it is minus J2.5. So simply we have to consider the particular element and then inverting that element. That is giving you primitive admittance matrix, Y matrix. This is step number 6. Now we are going to form step number 7. Step number 7 is nothing but forming a Y-base matrix. Y-base matrix is nothing but multiplication of A matrix, YP matrix, and then A transpose matrix. So already we derived A matrix. So this is the A matrix. So the size of the matrix, A matrix, it is given as 3 cross 6. We are going to multiply all the matrix. First I am going to consider the first two, A and then Y. Okay, so first A matrix, it is 3 cross 6, and then YP matrix, the size of the matrix is 6 cross 6. When you multiply two matrices, the sizes of the matrices, 3 cross 6, this is a matrix. When it is multiplied by 6 cross 6, the final size of the matrix after multiplication, you can see the first 6 and 6 will be cancelled. The size of the matrix will be 3 cross 6. This is the final matrix when two matrices are multiplied. So first matrix is 3 cross 6, second matrix is 6 cross 6, and then the net or final matrix when you multiply A and Y, that will be give you 3 cross 6. Right. So we are going to form AYP. So for multiplication of matrix, we are going to consider or multiply the elements in the row, elements in the column. You can see here, if you take the first one, there are 6 elements. So these are rows. So this is the first row, row 1, and you have to multiply with the first column. So this is the column number 1, C1. So how it is multiplied? We have to take the first element, multiply with the first element here, plus we have to take the second element and we have to multiply with the second element, plus we have to take the third element, we have to multiply with the third element, plus it goes. So how it is formed? Actually, we are going to take the multiplication. I will be taking the first value, I will be taking 1 cross J minus 5, this first row, this one and this one, plus, and then this one is multiplied with this one. So it is 0 multiplied by 0, plus this element is multiplied with the third element. So it is also 0 multiplied by 0, and the fourth element. The fourth element is multiplied with the fourth element. So plus 1 into 0, plus the fifth element is multiplied with the fifth element here. So this is the fifth element here. So 0 cross 0, plus last element is multiplied with the last element. So it is 1 multiplied by 0. So if you take here, so this becomes 0, this is 0, this is 0, this is 0, this is 0, leaving with only one value, that is nothing but minus j5. So this value comes as minus j.5 here. Okay, so this is the first element. Actually, what is the size of the matrix? It is 3 cross 6. So first among 18 elements, the first element is found. Similarly, we have to find this one. Similarly, you have to find this one. For finding this element, we have to consider same row, but we are going to consider column 2 here. Row 1, column 2. Same multiplication. Okay. And similarly for this case, we have to take the same row 1, and but we are going to consider C3, column 3. Row 1, C3, column 3. And similarly for this case, row 1, column 4, row 1, column 5, row 1, column 6. Okay. So same type of multiplication addition is to be carried out, and then we have to form these values. Right. So first row is over now. Coming to second one, same process is to be considered. So this is row number 2. So row number 2, these elements should be multiplied with the column 1, column 2, column 3, column 4, 5, 6. Okay, same type of multiplication. So after multiplying this way, we are getting these values. And similarly, for the third one, we have to consider row 3. So row 3, column 1, row 3, column 2, row 3, column 3. Okay. So similarly, we are multiplying and adding, we will be getting the matrix as A YP matrix is this one. Okay. So this one is the step number 7 actually. Actually, step number 7 is nothing but A YP A transpose. Now we formed only A YP. Now this matrix is to be multiplied with the A transpose matrix. Now what is the size of the matrix? A YP is 3 cross 6. Now we are going to multiply with the another matrix, that is nothing but A transpose matrix. So what is size of A transpose matrix? It is A transpose is nothing but 6 cross 3. Now the sizes will be 3 cross 6. Second matrix is 6 cross 3. Then the final size of the matrix will be this 6 and this 6 will be getting cancelled. So the final matrix will be 3 cross 3. So that is we are going to form. Okay. Now I am going to take this value AYP and then it is multiplied with A transpose. So this is AYP. Okay. So now this is, you can see here, this value is nothing but AYP matrix. I am going to multiply with the A transpose matrix. So I am going to add A transpose matrix. So this is nothing but A transpose matrix. We can see here the size of the matrix is 3 cross 6 here. This one is nothing but 6 cross 3. So this one and this one will be getting cancelled. So remaining 3 cross 3. So the final matrix we can get 3 cross 3. So same way we are going to perform. Okay. So we have to consider row 1. We have to take row 1 and then we have to take column 1 here. And multiplying and adding each element. So this one, J5 is multiplied with 1 plus this 0 is multiplied with this 0 plus this 0 is multiplied with this 0. Similarly, we have to perform. So once R1 is done, then we have to go for R2. Column row 2 should be taken. Similarly, row 3 should be taken. Okay. So after multiplying these, we'll be having the values as Y bus matrix is equal to A YP A transpose. So this is giving you the information regarding the Y bus matrix. So you can see here the size of the matrix is 3 cross 3. So this is what I told initially. The final matrix will be 3 cross 3. And you can see here among 9 elements, these elements are called as diagonal elements. Diagonal elements. All other elements are called as off diagonal elements. Off diagonal elements. And also all the off diagonal elements are symmetrical element. You can see here this value J is 2.5 will be here and J5 is here. Okay. So the place of this matrix, the place of this element is nothing but 1, 2. This is the place of element is 1, 1. The place of element is 1, 2, 1, 2. the place of this element is 1 3. Similarly, this place of element is 2 1. So normally for Y base matrix 1 2 is equal to 2 1, and this is 2 2, and this is 2 3, and 1 3, the value of 1 3 now, the element value is 3 1. So same value you can write, and this is nothing but 3 2, and this is 3 3. So 1 2 is equal to 2 1, 1 3 is equal to 3 1, 2 3 is equal to 3 2. So these value 1 2, 1 3, 2 3, 3 1, these are all off diagonal elements. 1 1, 2 2, 3 3, these are all called as diagonal elements. We can see here all the diagonal elements will be having the sign minus here. So minus, here it is minus, so here it is minus. All the off diagonal elements will be with the plus sign. So this is how we can form the Y base matrix. Okay, thank you.